right, here we go again with classification and regression trees learning. So last time I was wanting to see how scikit-learn trains classification and regression trees. So we're going to set up a debugger and try to train something. And then we'll see how it works, hopefully. Now, I want to see something in the sound settings. Yep, alright, this is good. Anyways, and by the way, if you are a human being watching this thing, which would be very surprising, you might be wondering, well, why are you streaming for absolutely no one? This thing has one viewer. In that case, it's not really, this is not intended for anyone, I suppose. But maybe in the future, if this gets higher quality, and if some people watch it, it could be useful. Like, I took inspiration from Soding Daily. Oh, that's scary. I need to change that photo. From Soding Daily. I really love his videos. They're awesome. I love seeing how someone else does things. So maybe it happens that seeing how I do things happens to be useful for somebody. But if not, it doesn't really matter. Okay. Right, so we're gonna need to set up Conda because that's how scikit-learn works. Yesterday I found scikit-learn documentation for building it. It's something like advanced installation. That's not advanced installation, that's just developer installation in my opinion, but okay then. Building a specific version, compilers, Linux. Right. Do they have anything about debugging? I guess not. Now it's been a long time since I debugged Python. And I was considering, should I use Visual Studio Code or something else? And I think I'm just going to use Visual Studio Code. Like, why am I making my life complicated? I just need to see how to set up Visual Studio Code with Conda. So let's look that information up. How to set up Visual Studio Code with Conda. So let's just say that for now. Install Conda, install Visual Studio Code, Python extension, I believe I have it. Okay, let's go to projects, scikit-learn, and then we're gonna do Visual Studio Code here. Probably has to update. Okay. Yes, I trust. And then let's see about creating a launch.json file. What is this? Why is it installing Golang? Whoa. Static check. Oh, I guess Golang is what the language server for Python is using. MCP support is now generally available in VS Code. Easily install and manage MCP servers with the MCP view gallery. That is cool. There's a CMake debugger? I mean, CMake is a language, yeah. That's kind of crazy. Okay. I didn't know that. Okay, let's go Python. I would just like you to set up. Should I do with arguments? Okay. Let's do prettier. And save. Okay. Debug Pi is the name. Yeah, I think that comes from... I think that's integrated in CPython. Okay. But now we also need conda, so... Where were we? Configure VS Code to use conda. Open the palette, select interpreter. VS Code will automatically detect your conda environments. Really? Python interpreter. Nice. Wait, why did conda not install the latest version? Oh man. Wait, this has venv? Oh man. I mean, okay, before we do that, I want updates. Can you cancel? How do you... Oh, there's a refresh button. Okay. How to update Conda environment? I want to update things because it didn't install the latest version of Python. Apparently there's also 3.13. So why the heck did it install like 3 point something? Okay. My scikit, conda activate my scikit. Good. And then what? Conda update all. Yes, that's what I want. Wait, what? No, this doesn't look good. That is so weird. It's downgrading setup tools. That doesn't sound right, but I don't know if I care. Let's just do it. What? I'm not good at using... No, that can't be it. Okay, you know what? Is this a thing? Yes, it is. Okay. How do you make a conda? How do you make a new? Let's just try to start from scratch, because this is not working out. Where's conda? Like, what if we literally just? But that's what I did last time, right? This is what I did, and then it ended up. Wait, when was this written? Update log files for scipdev CI builds. Oh yeah, I didn't. Ah, scheiße. I didn't completely clone this repository, so I cannot use git blame. All right. I cannot use git blame. Okay. Okay. Like, this is literally the command I ran last time, and it didn't work. Oh god, why do I get lost in this file, dude? Conda, Windows. Wait, I went way too far. So this is what they recommend. But last time I did that, whoops, last time I did this, I literally did this, and it still installed an old version of Python. Where Conda searches for packages? Yes, I imagine. This is a vast community-led channel with thousands of open source. It has packages that are not in defaults at all. Oh yes, that sounds legit. And so if I just do this, it's not going to install, it's really not going to install the latest version of Python. Really? Like, really, for realsies. Let's try. Okay. The following packages will be installed. Now it is. Bro, that's so weird. Okay. Then I guess this is gonna be fine. And this thing recommends reopening the terminal. I don't know if that's like, that literally doesn't change anything. So let's just go ahead and do it. Okay, now if we go Python version, we have 3.13. Nice. So now if we go here again and refresh this list, we have sklearn environment. So that's what we're going to use. But I believe I'm missing some steps. Am I? Nope. Install a compiler. build the project with pip. Yes, I did this last time as well, so now I'm just gonna have to do it again. Should I? Yes, I should. Okay, let's just do that. And that should hopefully work. That's gonna take a bit. It has to compile, and then we're gonna see if this works properly. But in the meantime, we can just use this environment. And now in Visual Studio Code, we are hopefully working with Conda. Now, is it gonna know about? Yeah, it should, because it's gonna run debug pi. I mean, of course, it has to run it. And then it's hopefully gonna know to pick it up correctly. I might have to restart, but we'll see. So when this compiles, we need to do like a quick test that we can actually debug scikit-learn. So basically we just need some scikit-learn location. Alright, I hate using, let's do, maybe let's just find where this show versions is. And there's 31 results. Of course. Now I'm wondering how hard it would be to set up Conda with Emacs. I don't think it will be too hard. I just need to point the language server. Well, the entire language server needs to use the proper environment. Wait a minute. LSP log. Yup. So basically I just use the pyrite from Conda. I think that would probably work. Depends, because then pyrite might depend on other things which also have to be from the Conda environment, so maybe it would work, maybe it wouldn't. Not so sure. Okay. Anyways, this is the function that prints versions. So this is what we can debug. So it's in show versions.py. So let's open that. Show versions. I think it's at the bottom, right? Yes, very good. Okay, and now let's first try running the thing from advanced installation. This thing. Does this work? Yes, good. And now we can try debugging. So we're gonna set a breakpoint here. Now, how does Visual Studio Code do debugging? It uses debug pi, request launch program file. Is there like debug configure add configuration? Oh god, doesn't it know this is Python? Debug the currently active, remote attach using process ID. But I kind of just wanted to this is not gonna work. I'm gonna need to right, if I run it from the terminal, then it's a bit wonky. I mean, I could set it up, but it's a bit wonky. I could add it as arguments. Yo, why is there no way to close this? What are you doing? Visual Studio blowed. Okay, thank you. Jeez. Okay. Yeah, so I'm thinking maybe it's best that I make a Python file for testing, and then in that Python file, I import scikit-learn. I didn't confirm that we're using the dev version. We are, okay. Right, so make a Python file here, do whatever I want inside of the Python file, and then do debugging that way. It's not the cleanest solution, but I think it should work. So what's the command again? But why am I writing in? Okay, whatever. Import sklearn. Show versions. Yep. Why is it called sklearn now? I'm not good at Python apparently. Sklearn.show versions. Okay. Did I modify something? I don't think I did. Don't save. Right, sklearn.show versions. And if I go into that function, I set a breakpoint here. So debugging this theoretically should start debug. Select and start debugging. Current file. That should start the debugger. And it does. Very nice, very nice, very nice, very nice. Okay, so let's just cancel that. Is this using... That is so stupid. Shouldn't the terminal be using conda automatically? I mean, I don't care. I'm not going to use this terminal, but I think that should be a feature. Kind of weird that it doesn't do that. But I don't care, whatever. Right, so we were doing all of this because I want to see how a decision tree gets trained. So where the heck, where is a base decision tree class? And there it is. Okay, we have the base decision tree class. And now there's this fit method somewhere. Okay, but there's also a problem. I don't think you can use a base decision tree. Yes, you cannot. Use derived classes instead, but do I have to? Like, what's gonna happen if I use it? Random state, check input and samples is classification. I'm guessing that criterion equals self.criterion. So I'm guessing that this doesn't have, I mean, it does. So what's the problem? Oh, criterion has to be an instance of criterion, right? And this is not something you're gonna do by just calling this base decision tree class directly. And I assume code is riddled with that stuff. And then when they implement a class like gradient boosting, then they take care of all of that stuff. Okay, but if I use the gradient boosting class, then there's going to be a lot of noise from other things that I don't care about, which is not great. Is there anything else? What else inherits from base decision tree? Base decision tree. Let's see what we have. Three classes, base decision tree, Regressor? Oh, right, of course. Just a classifier of regressor 3. Yes. Yeah, let's do that. Yes. I just need an example how to use this class. So let's ask. I'm gonna use exa. Should I use exa or context 7? I mean, context 7 is better, but I ran into some rate limits. Let's see what happens. Okay, let's close this and ask how to use decision tree classifier from scikit-learn. If you need documentation, use context 7. Okay, let's send that. No, I didn't. Abort. I didn't add tools. Silly me. Context 7. There we go. And then we can go again. Let's just kill this and go here. I'm wondering if I can okay, let's just show me the example. From datasets, import load iris. Oh, that is so cool. Yes, scikit-learn has datasets as well. That's awesome. I wonder, load iris, the iris dataset for classification. Classic and very easy multi-class classification dataset. I think I'm gonna steal that dataset when I do the C++ implementation. Yes, but what is the iris dataset? Let's do that separately. Iris. What is the iris dataset? It is mentioned in scikit-learn. So while we're waiting for that response, let's go read here. So load iris, train test split, create and fit the basic tree. Perfect. This is literally what I want. Oh my gosh, you can visualize the tree? That is epic. Hyperparameter tuning, cost complexity pruning. That's great. That's great. That's great. That's great. Should I kind of want to run this in Colab really quickly to see the tree visualization, but yeah, let's just do it. Doesn't cost us anything. So let's go to Colab, Google Colab, just to visualize this. And let's call this decision tree. Wait, what am I doing? That's a searching notebooks. decision tree. And let's pasta. What if I just run this pipe coding? Didn't even read it properly. I don't know if it works. I don't know if it has bugs. I don't think it does. It looks legit. You know, that's an impressive attempt to visualize the tree, but this is so cool. Because when I was learning decision trees, I was like, what is a tree? And then what really helped is that Gemini basically made this sort of chart with ASCII, and that helped a lot to understand the tree. So this split here, this splits here, this splits here, this splits here, yes. This really helps you understand, yes, it's really a tree. It has a test. It calculates Gini impurity. This is the number of samples that are in this node. And this is the class determined at this node. Interesting. Okay. Accuracy 0.933333. That's very good. Accuracy, probably. I don't know. I shouldn't say that, probably. Okay, nice. So let's, since that works, confirmed, let's put it into testing. Wait, didn't I make testing.py? Hello? Hello? Oh, I put it inside of a directory. Whatever. Testing.py. Let's just do this. Now this is gonna have errors because it doesn't know about conda, which is somewhat annoying, but whatever. And this is what I'm interested in, clf.fit. Okay, we're gonna debug that now. Let's take a second of a breather, 1 second to relax. Actually, I should probably go get some water, so I'm gonna do that very quickly. Okay, we're back. Time to debug clf.fit. Let's go in before it leads us to Cython code. That'll be fun. So let's is there like a convenient way to delete a file in Visual Studio Code so I don't have to click? Whatever. So let's go testing.py. Oh gosh. So let's close this. Oh my god. Where is it? There it is. Did I not save? I didn't save. Okay, so we want to break here and see what the heck happens. Let's do that. So let's start a debugger. Let's debug the current file. No module named matplotlib. Yes, we don't need that actually. So where is the plot? We can delete that. We can also delete this. So let's just go ahead, delete. Okay, stop the debugger and let's go again. Alrighty. Oh, I didn't read what the iris dataset actually is. Not that it matters too much, I suppose, but let's see. A small classic multivariate dataset used for demonstrating and training models. It was introduced in 1936. Bro, that is old. I wonder if, Ronald Fisher couldn't have been doing machine learning because there were no computers in 1936. That's for sure. So I wonder what he was inspired with. So, there weren't computers, there were other machines. I wonder if you could do any kind of machine learning on non-computer machines. I don't think you can. But let's not get too deep into the rabbit hole. So sepal, what the heck is that? Is that some plant thing? Yes, it is a plant thing. I do not know what is a sepal length, but it's some plant properties. Oh, iris is a flower. I knew it's a familiar word. Yes, iris is a flower. Right, so there are 3 species of iris. I get it. You get some flower properties, and then you have to determine what species of iris it is. Okay, gotcha. So let's step in and see where it leads us. Of course, it's a decorator. What else would it be? Decorator to run the fit methods of estimators within context managers. Now, estimators. That's a very abstract word, because like everything in machine learning is an estimator. But I assume it refers to something specific in scikit-learn. Maybe it refers to something specific in machine learning. So that's worth checking. Estimator. What is an estimator in machine learning? For example, scikit-learn mentions it. Anyways, so this is just like what does it do? So there's the fit method. And then it calls it. So what does it do? It sets name. Sometimes it changes the name. And it runs it with config context, which I'm gonna assume is just not relevant to us, but I'm just gonna keep it in mind that there is a context manager. So if we don't understand something, it could be related to context manager. But we don't care. 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 And we care. Let's step into. Yes. And then we get into the fit method of the decision tree classifier, which is good. This is the meat. This is what we want. And it literally just calls fit on the base decision 3, setting x, y, sample weight, check input, and return self. Okay, but we are in a debugger, thank God, so we can see stuff. So x and y, that's just the iris data from the data set. Sample weight is none, and check input is also irrelevant, right? Wait. Gosh, where is check input from? Wait, why doesn't it? Ah, there it is. True. Check input is true. Okay. But this is gonna first construct it and then gonna go into the fit method. So that's gonna be fun. Oh, it won't construct it. Okay. Yeah, no, that's why would it construct it? What am I saying? Okay, random state equals check random state. Okay, now we're cooking. Now we're cooking. Now we're gonna be able to see stuff and understand this code because we have runtime data. Hopefully, unless we get hit with some curveball, you know, like delegation to Cython, and then I have to see how do you debug Cython code. I wonder if you can debug Cython code. That's another reason why maybe it's better to write Python extensions, like just, you know, just use C++ or C or any other language. Because when you have a language, there's so much tooling around it, and you make a new language called Cython. Maybe I'm hating on it too much. I'm not hating on it. I don't mind Cython. I just think it's more robust if you don't use Cython. You get more tooling support. Okay, I'm getting distracted. Random state equals check random state. I do not know what that does, but it changes random state in self. So if I check that here, random state 42, interesting. And does it change? No, it does not. Wait, why does this say 42? And this seems to imply, what the heck is this? Okay, let's just assume this is correct, but I'm not sure at this point. Wait, what? Did this? What is this error? I'm getting distracted again. Okay. If check input, which is true, I'm thinking this is not relevant, right? Yeah, this is not relevant. So let's just go. This is just. I mean, I'm gonna need to do this as well. Compute missing values in feature mask. Actually, yeah, this could be relevant. I just need to keep in mind, you know, but that's kind of obvious. So let's just go forward. Oh my gosh, this context menu. Okay. Where is run here? Run to cursor. Oh my gosh, there it is. Okay. But why did I run here? This is not relevant. Is classification. Is classifier. Wait, what? Oh, yeah, because this is a base decision 3. Okay. Fine. Y equals NP at least 1D. Okay. That's fine. Okay, it reshapes the data. the output data. I always see this, like, I'm really not used to NumPy and all these cool machine learning libraries. What does -1, 1 mean? I didn't read about estimators. Okay, I'm not gonna get distracted right now, because if I go down every rabbit hole, I'm never gonna get anywhere. Okay, so in NumPy, what does reshape 1, is that how you write it? Yes. -1, 1, do. I don't know if I explained that too well, but I think it's gonna figure it out. Okay, if is classification, which it is. Okay, let's run the code. Check classification targets. Now, what does that do? Ensure that target Y is of a non-regression type. Only the following target types: binary, multiclass. Oh, okay. This is just like validation. Okay, so none of this is actually doing anything. Neither is this. Blah blah blah. Doing some copying. Whoa, chill. Looks like we're getting to the meat of it now. Okay, so we're going for k in range of self dot and number of outputs. Which, what does that refer to? Does that refer to the number of classes? Does that refer to the number of samples? What does that refer to? Okay, so that's the shape. Y dot shape 1. Can I? Oh, I can. That's awesome. So if I execute this, we get the value. That's cool. Okay, so y dot shape 1. Yes, so output shape 105 to 1. Okay. This is, what is the point of this loop? Classes K, Y encoded, everything K. Okay, this is a bottleneck because I don't really understand the structure of Y, which is unfortunate. Like, wait, what does this do? Reshapes the array into a 2D column vector with 1 column. Okay, that explains everything. It's a vector now. So you have 105 entries, and each one describes the result for stuff from X. So this selects literally all of the outputs. This literally can be replaced as meaning all of the outputs, and it works differently when you have multiple outputs, but for the purpose of our example, you're gonna have one output, and then here it determines what are the possible classes. So it takes unique things from Y. Wait, what is Y encoded? NP0s, Y shape, D type, int. Oh, I see. Right. Y encoded means that the classes are encoded. Okay, so the classes are encoded. And then self.classes append classes k, self.end classes append. Okie dokie. So this is still just initialization. When are we getting to the meat? This is still just initialization, I think. We're just setting variables. Okay, here we set the splitter. We create. Oh no. Okay, no, we're fine. Are we fine? Oh, don't tell me it happens in the tree. No, it can't possibly be because the tree. Oh my gosh, does it know? Wait a minute. So number of classes, number of outputs. I don't think you can. I don't think the algorithm runs in the tree. Use best first if max leaf nodes given. Use depth first, otherwise depth first tree builder or best first tree builder. And then builder.build. I believe this is where it happens. But that is Python, of course, isn't it? Ugh. Wait, what? Where the hell? Wait, whoa. What is this path? Oh my gosh, that's gross. No, that's not. Why are you? Okay, depth first tree builder. Oh gosh, it's because it's in Python. So it can't even find it, can it? Depth first tree builder. Yes, of course. Ugh. Well, that's gross. I mean, it's good. It would suck if they, like, imagine if they did training in Python. That would be too slow. But I cannot. Well, I shouldn't probably bother with setting up a debugger for Python. So instead, we're just gonna read this, or I'm gonna read this, and I can actually modify the code and recompile it. Yes, I can do that. And that's what I'm gonna do. So if I want to know something, I'm just gonna be like print, you know, the noob way. Actually, we also have an LLM, right? Thank God. So I don't need to know Python syntax. Okay. So I gotta read all of this. This is the description of how the tree gets built. Wait, before I say that, let me actually make sure that's true. It runs splitter.init push root node onto stack while not builder stack empty is leaf. Yeah, so this is part of it, and part of it is also splitter, which I need to find where the heck it is. But yeah, it's this thing and the splitter. And I think I'm gonna leave it there and leave this for tomorrow because I'm getting sleepy, which is surprising. It's only 10:25, but I feel sleepy. My brain is not working too well right now, which is a shame. I wanted to do this for longer, but it's all right. Maybe we can do it tomorrow for a longer time. For now, let's just write this down. I just want to make sure it's actually best first 3 builder. Is that also here? Best first 3 builder? Yep. Okay. Training code is written in Python. And the other one, depth first 3 builder. Classes, build method, and that is in sklearn 3.pyx. Right. Yeah, and tomorrow we check how this works, and we're gonna have to write some Python code potentially to do some printing and tinkering with this to better understand how it works. But for now, I'm out.